Yes, now we move on to the problems on this thermal model. So I request you to keep notes with you always. First, you keep notes with you while seeing these videos, while watching these videos. If you have notes, it is better to understand. You'll understand easily. Or and one more thing is that you should have pen and one page with you always. Keep on writing the things. You'll understand the things. Now, so temperature rise of the motor when operating for 25 minutes on full load is 25 degrees Celsius and becomes 40 degree when motor operates for another 25 minutes on the same load. Determine heating time constant and steady state temperature rise. So in this case, what you have to study is that we have to study two things. We have to calculate two things here. One is the heating time constant tau. Tau is the heating time constant. Theta SS, it is the steady state temperature rise. Two things we have to calculate here. Two things we have to calculate. For that purpose, what he has given temperature rise of the motor when operating for 25 minutes on full load condition. For a first 25 minute, temperature increment, motor is operating, temperature is rising, motor is operating, temperature rising. Motor is operating for how much time? It is operating for 25 minutes. First, temperature rises to 25 degrees Celsius. So first this condition you can use. From this condition, first what is the formula we have? We have the formula theta equal to theta s is 1 minus e power of t by tau plus theta 1 e power t by tau. Theta s is the steady state temperature rise. We don't know that. And theta 1 is the initial value and t is the time given, tau is the time constant and theta is the final temperature rise we have to calculate. For a first case, only for this case if you consider, so for this case if you consider, so what is the initial temperature rise here? It is starting from 0. So it is, say it is equation number 1. Starting from 0, so means what? From this equation theta 1 will be 0. Next, what about theta here? This is the final temperature rise. Finally it is reaching to how much? It is reaching to 25 degrees Celsius. So final temperature is 25 degrees Celsius. Initial is 0, so actually it is plus 0. So theta s we have to calculate, and t value is how much? 25 minutes. Tau value we have to calculate. It is the equation we have got first case. Next, for second condition, if you take what is second condition has given? And becomes 40 degree when operating for another 25 minutes. It is operating for another 25 minutes and temperature is reaching to 40 degrees Celsius. In that case, what happens here? Another 25 minutes it is operating and temperature is reaching to 40 degree. If you take second condition, if you take this condition, what happens here? So for a second condition, if you take starting from 25 reaching to 40 degree, it's taking 25 minutes. Starting is 25 reaching to 40. So for a second case, initial temperature rise theta 1 is 25 degrees Celsius, which is the final temperature rise 40 degrees Celsius. So theta 1 is 25, final is 40. So how much time it is taking? Again, it is taking 25 minutes only. So theta 1 initial temperature rise for the second case is 25 degrees Celsius. Substitute that. Final is 40. Theta s is 1 minus 25 by tau plus 25. So it is the temperature, it is the time. It is temperature, it is time. So those things we have added here. We have got the another equation. So from in this, how to solve these two equations? These two equations how to solve means what? We check the second equation. What is second equation? Theta SS, this much part we can see here. Both are same. Both are same. So how much it is equal to? This part is equal to how much? 25. Just substitute here. 40 equal to 25 plus 25 e power 25 by tau. The whole part will be replaced by this 25. So 40 minus 25 equal to 25 of 25 e power minus 25 by tau. Then it is 15 by 25 e power 25 by tau. And taking ln, to remove this e, we are taking ln. What is ln here? It is log with respect to e. That's why ln we have taken. So if you take ln, there is a property of log or ln property is that if you take ln here, whatever is part is coming, that is coming to front side. So taking ln on both sides. So taking ln on both sides, you will get, if you take ln on both sides, so we will get tau is equal to 4894. And from equation number, then this you have calculated. So what is that? Tau we have calculated. Tau we have calculated. This tau you substitute in equation number 2, you will get the theta SS. That's it. So this 48.94 you have calculated, substituted here, we'll get the theta SS. So tau value calculated, theta SS we have calculated. Tau value is in, it is the time constant. Theta SS is the steady state temperature rise. It should be in degree. It should be in degree always. So one assignment is also given. You try that.